Today we're going to begin looking at section 5.5, which is all about graphing sine and cosine functions. So we're going to start understanding what the graph of y equals the sine of x is. Same thing with the graph of y equals cosine of x, and then we'll start looking at some different variations of the two. So in order for us to know how to graph the sine of x, we actually can relate that back to our knowledge on the unit circle. So using the unit circle, we can create essentially ordered pairs that will help us then create the shape of the graph. So notice that I have this table. I've got the x values already given to us. When you're thinking about the unit circle, we're going to be thinking about it in terms of radian values. So I just put some of the main radian values. I did it mostly just with the thinking 30, 60, 90 triangles. So I left out the 45, 45, 90 triangles, but this is going to help us get a good idea of the shape. So if you're thinking about your unit circle and you're thinking 0 for your value, remember in an ordered pair for your unit circle, we were always thinking cosine was first and sine was second. So if you're using your flip books, you can look at all of the second numbers in our ordered pairs at these particular radian values. And so what you would see is that at 0, sine is 0. At pi over 6, sine is a half. At the pi over 3 value, it's a radical. It's the square root of 3 over 2. So I just abbreviated it as a decimal. It's approximately 0.87. At pi over 2, we're at 1. Moving on to the second quadrant, at 2 pi over 3, we're at 0.87, then a half, then 0. And then in the third quadrant, we move to the negative values. In the fourth quadrant, we're also negative. And then at 2 pi, we're back to 0. So if you think about those ordered pairs, it's going to create a picture that looks something like this. So once again, notice that my x-axis is all the radian values, and the y-axis are all of those numbers that we got for our decimals, okay? So notice that it's forming a curve. It's going up, then it's going back to the x-axis, then it's going down, and it's curving back to the x-axis. Okay, so this is what your basic sine graph looks like. Okay, and notice how in this picture I'm labeling it, it's called a period of 2 pi. So we'll talk a little bit more about that in a second, but understand that the basic shape of a sine graph looks like this, starting at 0, 0, heading up, going back to the x-axis, heading down, and then going back to the x-axis. So let's talk about then the general form for graphing the sine. We will see something like y equals a times the sine of bx. We've got a couple of vocab words here. So amplitude. We want to talk about amplitude when we're talking about the height of the graph. So that's going to be represented by the letter A. Now, when we're actually identifying the amplitude, we want the absolute value of A, but understand that A itself could be positive or could be negative. But when we describe the amplitude, we're thinking positive numbers, so we're taking absolute value. So then, like I mentioned in that picture, we have something called the period. The period is going to be one rotation around the circle. Okay, and so because we did one full unit circle for our sine, which starts at 0 and goes to 2 pi, how we'll calculate the period is we will take 2 pi and divide it by the absolute value of b. So notice b is located as the number that's connected to x. It's a part of the actual sine itself. So the quickest way for us to then graph our sine, just like with parabolas, I asked for 5 points, or when you're graphing a line, I want 3 points. So when we're graphing these trig functions for sine, I want 5 points. So here is the basic definition of how we find those 5 critical values for sine. If you remember our picture, it starts at 0, 0. And then essentially the full rotation is a full period. So that's why at the very end, I have the period, comma 0. Because remember, if you think about how it was in our picture, notice how if I go back to the picture, we are touching the x-axis not once, not twice, but 3 times. So it starts at the x-axis and it ends at the x-axis. And notice halfway, we're on the x-axis. So that's why when I'm thinking about my critical points, we're going to be on the x-axis not once, not twice, but 3 times. And so then understanding that we're essentially breaking up that full rotation into fourths, thinking about you got 4 quadrants in a circle. So whatever the full period is, I want a fourth of it, half of it, 3/4 of it to help me get the rest of my ordered pairs. And then the A value, which is our amplitude, is going to help us with the rest of our critical values. I want to be going up first, so that's why it's going A, and then I'll go down after we get to the middle point, so that's why it's the opposite of A. All right, so with those 5 critical points and the information of A is an amplitude and B is helping us find the period, let's go ahead and start looking at some examples. So you're obviously going to want graph paper for this. We are going to determine the amplitude of y equals 3 times the sine of x, and then we're going to graph one period of this function. Okay, so once again, my basic definition is y equals a times the sine of bx. Amplitude is always the absolute value of a. So notice that in this particular problem, my amplitude is going to be dealing with the number 3. Obviously, taking the absolute value of 3 is going to give me 3. So there's my height. I am going to want to calculate the period. So even though it didn't specifically ask me to determine the period, we're going to need it in order to graph. So if you think about our definition, remember it's going to be 2 pi because that's like one full circle around our unit circle. That's one full rotation around our unit circle. And we want to divide it by the absolute value of b. Well, notice that I don't see a number in front of the x, so it's technically a 1. So the absolute value of 1 is 1. So 2 pi divided by 1 is 2 pi. So we're going to use those two numbers to find the 5 critical points. So once again, when we're talking about a sine graph, we always start with the ordered pair 0, 0. The next thing that I want to do is I want to take a fourth of the period. So once again, my period is 2 pi. So I want to take 2 pi and multiply it by a fourth. So if you need to, keep it as 2 pi over 1, multiply by that fraction, you're going to want to reduce, and so it's going to turn then into pi over 2. So once again, we're taking 1/4 times 2 pi over 1. That got me this value. So then remember the second half of that ordered pair is our A value. So even though the amplitude is the absolute value of A, 3 is our A value. So that's going to be the second half of that ordered pair. So it's pi over 2, 3. The next ordered pair is I want to take a half of the period. Once again, my period is 2 pi or 2 pi over 1. So half of that is going to give me pi. Remember, that's when we're back on the x-axis. The next ordered pair, I want to take 3/4 of the period. So if you think about multiplying straight across and then reducing, 6 pi over 4 is going to reduce to 3 pi over 2. Then I want the opposite of A. So since A is 3, we want then -3. And then finally, we want our full period. So that was the 2 pi that we calculated. And remember, we're back on the x-axis. So there are my 5 critical points. The next important thing that we have to do before we plot those points is we have to label the x-axis. Okay, so we want to use our radian values, but we have to be consistent. Just like if I'm going to erase this in a second, but notice how like I can't say that this is a tick mark of 1, this is a tick mark of 2, and then I can't say that's a tick mark of 4. It doesn't make sense. I want to stay consistent. So understand that wherever I start at 0, the next number pi over 2, that means that wherever I put that value, I need to go then the same distance away to get to the next x value in my ordered pair. Okay, so I'm going to make it every 2. So I'm going to make pi over 2 the second tick mark, which means I need to go 2 more over to then say pi, and then 2 more over to say 3 pi over 2, and then 2 more over to say 2 pi. So then technically I could even go in the opposite direction. 2 to the left, that would be negative pi over 2, and so on and so forth. But I need to be consistent there, okay? So since I put 2 tick marks before I actually labeled, I want to then go every 2. Okay, notice that I already have the y axis labeled for us. So now we can then just plot our points. So 0, 0 is here in the middle. I go over to pi over 2, and now I want to go up to 3. Over at pi, I'm back at 0. At 3 pi over 2, I got to go down to negative 3. And then at 2 pi, I'm back at 0. Now remember, I want this to be a nice curve, so don't make them V's. And I want arrows indicating that technically I could go from my 0, 0, and I could go to the left, but it's actually then it would be heading down. So there's my arrow indicating that I could be going in the opposite direction on the left, but now I'm going to start connecting my points. So once again, there's a curve to them as I'm connecting those points. And then once I get to the 2 pi, don't just stop there. We have to continue. It would then head back up towards 3 again. So I want an arrow indicating that I know that the next time around, I'm going to be heading back up to 3. And there is one full period of my graph. Okay, let's take a look at another one. Once again, we're going to determine the amplitude and the period, and then we'll graph one full period. So my a value is always the number that's in front of the sine or whatever trig function, and then the b value is going to be connected to the x. Okay, so there's a and b. So remember, my amplitude is going to be the absolute value of a. So notice this time, since a is negative, the absolute value of a negative, my height is positive 2. My period I get by taking if I take 2 pi and I divide it by the absolute value of b. Well, since b is a positive number, the absolute value of a positive is still a positive. So now because I'm dividing by a fraction, I can think of it as multiplying by the reciprocal. The reciprocal of 1/2 is 2. So 2 pi times 2 tells me 4 pi is the full period. So now that I have those two things figured out, we can list our 5 critical points. Because we're dealing with a sine graph, we start at 0, 0. Once again, my period is now 4 pi. So I want to take that, and the next number is a fourth of that. So if I want to think of it as 4 pi over 1, that's fine. But a fourth of that is going to turn then to pi. Remember, I want my a value. So it's not 2, that's the amplitude. In this case, a is negative 2. Then I want to take half of the period. So if I'm thinking about half of 4 pi, that's going to simplify to 2 pi. Remember, that's when we're back on the x-axis at 0. Then I want 3/4 of my period. So when I multiply that and simplify, we're going to get 3 pi. And then I want the opposite of a. So since a is negative 2, the opposite of a negative would make that a positive 2. My final ordered pair is the full period, so 4 pi. And remember, that's when we're back on the x-axis. So now that I have my critical points, I want to label the x-axis, and I want to label it consistently. So same thing. However far away I decide to put the pi, that's how many tick marks I need to continue to then do the 2 pi, and then the 3 pi, and then the 4 pi. So once again, I think I'm just going to do 2 tick marks. So the second tick mark is pi. 2 more over is 2 pi. 2 more over, 3 pi. 2 more over, 4 pi. Do the same thing going in the opposite direction. 2 to the left, it'd be negative pi. And then 2 more over would be negative 2 pi, and so on and so forth. Okay, I already have the y-axis labeled. Let's plot our points. So we got 0, 0. Then at pi, I want to go down to negative 2. Back up then at 0 at 2 pi. 3 pi, I'm up at positive 2. 4 pi, I'm back at 0. Okay, once again, I want that full period. It needs to be a nice curve, but I need arrows on either side. So this time, notice that my graph is heading down first. So that means that on the left side, it must have been going up in order for me to then start heading in a downward direction. So I'm going to curve that, come back up to the 0, go back to the height of 2, curve, come back down to 4 pi at 0, and then that meant that the next thing would be, it would be heading down to get back to the negative 2. So here is a picture of my sine graph. All right, now let's talk about cosine. So once again, I want us to understand the basic shape of a cosine graph by knowing our unit circle. So if you have your unit circle, once again, remember I talked about it, cosine is always the first number in our ordered pair. Once again, I'm thinking about just my like 30, 60, 90 coordinates here. So if I'm looking at the first number in my ordered pair, at 0, it was 1. At 30 degrees, which is pi over 6, that was that square root of 3 over 2, which I turned into then a decimal as approximately 0.87. At then pi over 3, we're at a half. At pi over 2, we're at 0. Moving into the second quadrant, that's when cosine is negative. So I head towards my negative numbers. Third quadrant, we're also negative. Fourth quadrant, we're back at being positive. So that ordered pair, all those ordered pairs, create a shape that looks something like this. Okay, and so I know that this picture kind of extends that cosine graph a little bit farther, but if you look at what's highlighted in the darker blue, notice how it starts high, it goes low in the middle, and it ends back up high. That is what the shape of a cosine graph looks like. So now let's talk about the definition for cosine. So I'm using the same idea as sine as far as y equals a times the cosine of bx. Amplitude is still the absolute value of a, which represents height. My period is one full rotation, which is 2 pi. So 2 pi divided by the absolute value of b is going to make that calculation happen. I do want 5 critical points, but this time my ordered pairs are a tiny bit different because I don't start at 0, 0 on a cosine graph. This time, remember, I start at the height. So I start at 0a. I still want to break my period up into quarters. So the rest of the starting points of my ordered pairs are the same. It's a fourth of the period, half of the period, 3/4 of the period, and the full period. But notice that this time my y values are different because notice this time I'm only touching the x-axis 2 times, while with sine I was touching it 3. Because going back to the picture, notice that I'm only touching it twice. I'm at my highest spot twice, and I'm at my lowest spot there in the middle. Okay, so here are my 5 critical points. So let's use this information to graph a couple of cosine graphs. Okay, so we're going to determine the amplitude of y equals 4 times the cosine of x, and then we will graph one period of this function. So remember, my a value is always the number that's in front, and my b value is always what is connected to the x term. So my amplitude is the absolute value of a. So since a is positive, my amplitude is going to stay positive. My period, remember, I calculate that by doing 2 pi divided by the absolute value of b. So once again, if I don't see a number connected to x, it's 1. So my period is 2 pi. So we're going to use that information to find our 5 critical points, where once again, I want to focus on my period being 2 pi. So now this time, remember, I start at 0, but not 0, 0. I start at 0a. Since a itself is a positive 4, that means we're at 0, 4 to start us off. Then I want a fourth of the period. So once again, my period is 2 pi, so think of it as like over 1 if you need to. Multiply straight across and simplify, we get pi over 2. And then remember, this is when then we head and we hit the x-axis. So that's why my second part is 0. Then I want to take half of the period. So half of 2 pi is going to be pi. And now I want to go to the opposite of a. So the opposite of 4 would be negative 4. Then I want 3/4 of the period. So 3/4 of 2 pi would be 3 pi over 2. This is when I'm back on the x-axis. So 0 is the second half. Finally, I want the full period. So that's 2 pi. And remember, I end at a. I start at a, I end at a. So that's 4. So once again, when I'm labeling my x-axis, I'm going to be consistent. I'm going to do every 2 tick marks again. So pi over 2, 2 more overs pi, 2 more overs 3 pi over 2, 2 more overs 2 pi. So let's plot those points. 0, 4 is up here. Pi over 2, 0 is on the x-axis. Pi negative 4 is down here. 3 pi over 2, 0 is on the x-axis. 2 pi is back up at 4. Once again, just like the sine graph, we want curves. And so the highest and the lowest point, you need a curve to it. So please do not point an arrow up. If the amplitude is 4, I am not going any higher than 4. So I'm going to start my graph with a nice curve where I'm going to then be hitting that 4 and then curving down. So notice that now I'm heading towards the x-axis. I'm hitting that. And then I'm going to the lowest point, curving, and now I'm heading back up. I hit 0, and then I go to my highest point where once again, that is the highest point. So I have to curve down right away. So this is my graph. Okay, looking at another example, we've got y equals negative 4 times the cosine of pi x. So remember, the a value is connected to the cosine, the b value is connected to the x. Let's identify the amplitude and the period to help us find our 5 critical points. Amplitude is always the absolute value of a. Since a is negative 4, the absolute value of negative 4 is positive 4. The period is going to be 2 pi divided by the absolute value b. Well, b is positive. It's a positive pi. So notice that this time, 2 pi divided by pi, my period actually is just a number, not with pi. It's just 2. All right, so now using this information, we can do our 5 critical points. So remember, we don't start at 0, 0, we start at 0a. My a value is a negative 4, so 0, negative 4 is where I'm going to start. Remember then, I want a fourth of my period. Well, this time my period is just 2. So a fourth of 2 is going to simplify to a half. Remember then, I'm at the x-axis, so 0. Then I want to take half of the period. So half of 2 makes it 1. This is when I'm at the opposite of a. So the opposite of a negative 4 is a positive 4. Then I want 3/4 of the period. So 3/4 of 2 is going to simplify to 3 halves. This is when I'm back at 0. Then I want the full period, which is 2. And remember, where I start is where I end. I want to end at a, which is negative 4. So when I'm labeling the x-axis, this time, if you want, you could go each tick mark as a half, but there's no need for pi. So if I have 1/2, 1, 3 halves, 2, you can make it like that, or you could do every 2 like I've done in the past. But I think I just want to show you a little bit differently here. So each tick mark, I'm making a half. So I want 0, negative 4, and then 1/2, 0. 1, I want positive 4. 3 halves, I want it 0. 2, I want it negative 4. So once again, notice that this time I have my lowest point starting, but that means that negative 4, I don't want to go any farther. So I want to have a curve at it. So notice how it's going to be curving back up on the left. So over here on the right, it curves up to that 1/2 at 0, curves up to positive 4, and then curves down right away. So I can get back to that x-axis at 3 halves. And so then I can get down to that -4, but once again, notice how I'm curving right away. I don't want to go any lower than -4. And there is my cosine graph. So I would suggest you pause the video and try this checkpoint problem. Notice that this time it's y equals negative sine of 1/4 x. Okay, so identifying my a value, a was -1, so the absolute value gives me an amplitude of +1. Since my b value is 1/4, when I divide by 1/4, 2 pi divided by 1/4 is like 2 pi times 4, so my period is 8 pi. So here are my 5 critical points for sine. You should have gotten 0, 0, 2 pi -1, 4 pi 0, 6 pi 1, and 8 pi 0. Once again, notice how there's a curve to it, and I've got arrows on either side. So that is us understanding both sine and cosine graph and starting to look at different variations of them.